actually ties back into the textbook itself. So if you're one of the students that checked out a copy, it'll be in chapter 12 in the textbook, sections 3 and 4, and actually point 2. So you can tie back to the textbook, but it's still part of our chapter 3 or unit 3, if you will. So we're looking at matter, property, and changes. In this case, we're going to look at calculate the percent by mass of an element in a given compound. So a compound, again, is a multiple of atoms that are all chemically bonded together. So we take one of those atoms, how much mass does it contribute to the rest of the compound's overall mass on a percentage basis. So definition, percent by mass or composition, how it's made up. It's a ratio of the mass of each element to the total mass of the compound. So we looked at water. It's got hydrogen and oxygen. What percent by mass is the hydrogen, each at 1 gram per mole, versus the oxygen that contributes 16 grams per mole to the water compound itself, which is 18 grams per mole if you add those all up. So we look at hydrogen as a percentage and oxygen as a percentage. So it's that kind of an idea here. So from a formula standpoint, and again, when you have homework, write the formula down, plug in the values, show the steps in the work. Just don't give me an answer. So percent by mass is the mass of the element divided by whatever element you're talking about. There could be multiple elements. You can talk about each one of them. It's the mass of each element divided by the mass of the compound. That's going to give you a decimal number. Then we're going to multiply by 100, basically move the decimal over 2 places to get that as a percentage. So for example, we have 78 grams of some unknown compound. Somebody brings it into you, we don't know what it is. But you run a mass spectrometer, it's a special machine, it comes back and says, hey, of that 78 gram sample, 12.4 grams of that is hydrogen. So what percent by mass of hydrogen is in this unknown compound? Again, that's our formula there. So we take the mass of the element divided by the mass of the compound. So I try to do it in colors. Green is the compound, red is the element of interest. In this case, hydrogen. So the mass of the element is 12.4 grams of hydrogen divided by the mass of the compound. It's a 78 gram compound. We don't know what it is, but it weighs 78 grams that they brought into us, times 100. So we take, according to this formula, take the mass of the element, 12.4 grams of hydrogen. We're going to divide that by the 78.0 grams of the compound. This particular compound, we don't know what it is, but like on this particular element, we're showing that we have some kind of atom in the middle, and we have these little hydrogen atoms that are bonded to it, and they together weigh 12.4 grams. Times 100. So in this case, we'll plug it in. We're taking this formula, mass of the element, 12.4 grams of hydrogen, divided by 78 grams of this unknown compound. So we plugged it in to our little formula, times 100. You take 12.4 divided by 70.0, you get 0.1589. I put the next decimal here for rounding purposes because I like all percentages to be carried out to 2 decimal places, properly rounded, and the rule of 5 says we're going to round up since this is 7. But there's my decimal equivalent of these two divided. And now I'm going to take it times 100 to move the decimal over to give me a percentage. So that becomes 15.89%. The next number is a 7, so it means I got to round this up from 89 to 90. So it'd be 15.90%. So for this unknown compound, hydrogen makes up 15.90% of its mass. Whatever else is in this thing makes up the difference. But for the particular element hydrogen, that's the mass that it contributes to this overall compound. Here's another one. It gets a little bit of a different twist, but it's about the only 2 ways I can ask you something, guys. In this case, I have a compound that's 15.0 grams of hydrogen and 120 pounds of oxygen. It could be hydrogen peroxide, it could be water, we don't know at this point. What's the percent by mass of the oxygen in this compound? So the red. So we take the mass of the element we're interested in, oxygen. It's 120 grams, not pounds. So we That's the mass of our element that we're interested in, divided by the mass of the compound. Well, I don't know the mass of the compound. They didn't tell me that. But we only have two elements being involved here. Hydrogen and oxygen make up this compound. They didn't tell us about anything else. So those are the only two elements in this compound, like water, like hydrogen peroxide, like the hydroxyl anion, which we have not talked about. But the things that made up of hydrogen and oxygen. So that's the oxygen. This compound has both hydrogen in it. They gave it to us there, 15 grams. And it has oxygen in it. So it's an OH compound. If you add those two masses of the two components in there, I'm going to have the mass of the overall compound. And I'm interested, well, what does hydrogen contribute to the overall mass? Well, I got to add them together to find out what the overall mass is. Then times 100 will give me a percentage. In this case, I just simply bring the 120 grams of oxygen, that's what I'm interested in, over, you add these two together, you get 135 grams of this HO compound. It's hydrogen and oxygen. We don't know what it is yet. That's where we're working towards. So I got 120 grams divided by 135 will give me 0.8888 with a middle 8. I carry it out to 5 because I'm going to end up carrying this out to 2 decimal places when I'm done, and I want to round. So at times 100 will move my decimal over 2 places to 88.88. The next digit's an 8, which the rule of 5 says I round this one up. So this will become a 9. So it becomes 88.89%. So whatever this compound is, oxygen makes up 88.89% of this. Vast majority of this compound by weight. Hydrogen makes up the difference. In fact, if I want to find the hydrogen, I subtract this from 100. That'll be the percentage for hydrogen. In the future, you're going to be tempted to do that, but be real careful, because if you got this off a little bit, then that percentage will be off as well.